Hey guys, welcome back to Creative Coding. This is week 4, and today we are going to be talking about repetition, decision making, and randomization. So let's begin with repetition. So patterns and repetition can be found all around us. Our ability as humans to find repetition has helped us advance as a civilization. We see patterns in nature to help us survive the changing seasons. We see patterns in humans and animals to better understand their behavior. We see patterns in the stars to help us travel across the oceans. And because of this fascination with patterns, we use repetition for everything from fashion, for designing patterns for clothing, interior design using patterns to decorate our walls, sheets, and floors, packaging design to add texture and movement to our objects, graphic design to give flat designs more energy and life, and of course the fine arts. Soloit is a great artist to look at when discussing repetition as well as design systems. As an artist, he came up with instructions on what to make and had other artists actually create the work. You can think of his instructions as code and the artist as a computer. This is a piece from 1977, and these were his instructions. On black walls, all 2-part combinations of white arcs from corners and sides, and white, straight, not straight, and broken lines. Obviously, that can be interpreted in many different ways. In design, repetition can also be used to add more to a static piece. Here we are using repetition to imply movement. Having 3 hands repeating on top of one another implies that the hand is moving down and pressing on the key. Here we're using repetition to imply pacing or rhythm in a children's book. This piece uses repetition to guide the user's eye to a specific point on the page. It also makes the static image look 3-dimensional and implies depth. And of course, we can give the design a textural feel by using patterns. So let's take a look at how we can create patterns using code and create repetition in code. So we are going to be using something called a for loop that is going to basically loop through a few lines of code a certain number of times. So this is a for loop. It starts with for. Then inside we have a variable, I, and we initialize that by saying it's equal to 0. Again, you could change that to whatever you want, but traditionally you start at 0. Then we have a test here. So I is less than 5 for testing to see if I is less than 5. And then the last thing is an update. So we're updating this I value, this variable value, 1 each time we loop through this. So it's going to start with 0, and 1, 2, 3, 4, and 5. And then stop there because 5 is not less than 5. So this is going to loop through this rectangle 5 times. And we could use that I variable, this is called an iterator, to move something like a rectangle across the screen, or change the size, or change the color based off of this iterator. So each time this number increases, we're going to change in this case, the x location of this rectangle by multiplying it by the 21 value times I. So the first value is going to be 21 times 0, which is 0. And then 21 times 1 is 21. 21 times 2 is 42, etc., etc. So that's how we get this pattern moving from left to right on the screen. So before we knew about for loops, we basically had to draw everything by hand individually. So we had to go line by line to draw each one of these rectangles. So this is 1, 2, 3, 4, 5. This is 10 rectangles. So we're looping through this 10 times. And before, we would have had to draw 10 individual rectangles, change the location of that rectangle, change the color of that rectangle as well. But now using a for loop, we can loop through this code 10 times, change the color value based off of the iterator. So it's 36 times I. And then also change the location of the rectangle based off of the iterator, the variable I. So it's going to move each time it loops through it to the next location. So it takes much less code, just a few lines of code, to create something that used to take 10, 20, 30 lines of code, depending on how many of these you're going to create. So repetition is better created using for loops rather than writing line by line your code for all of those individual pieces. So we also have a few different options in our for loops, so we don't have to change the iterator by 1 every time. We don't have to increase it by 1. We can do whatever we want, basically. So if we did want to increase it by 1, you could do what we did before, was the value plus equals 1, or I could just say I plus plus, and that's just going to add 1 each time. You can also do the opposite by doing I minus minus, and that's going to subtract 1 each time if you wanted to go the other way. Plus equal is going to take the current value and then add whatever value is after this equal sign. So we say I plus equal. So if we say I plus equals 5, then the I is going to increase by 5 each time. You can do the same thing with subtraction. So I minus equals 5 is going to decrease by 5 each time. Same thing with multiplication. It's going to multiply by whatever value. It's in this case 5 each time. And division, you could do the same thing. I divided equals 5 is going to divide by 5 each time. So here are some examples of using different types of syntax for the iteration. So here we're just doing I plus plus, and we're iterating the location of the rectangle each time we loop through this. And we're looping through it 5 times. So it's going to start with a rectangle at the 0, 0 point. Then another rectangle is going to be drawn at the 21 for x. Then the next is going to be drawn at the 42. Then the next is going to be drawn at the 63. And the last is going to be drawn at the 84 for x. So it's just moving from left to right in a pretty steady pattern. The next one, we're doing I plus equals 3. So this is going to update by 3 every single time. So it's going to start at 0. Then it's going to add 3 to that. So it's going to be 3. And then it's going to add 3 to that again, which is 6. And then 3 to that again, which is 9. And then it's going to stop there because that's the test. So this is going to be 20 times I. So it's going to be 0 first. And then 3 times 20 is 60. And then 6 times 20 is 120. So that's why this is spacing out larger, because it's a larger iterator each time. And then here we're doing I multiplied equals 2. So we're iterating, but we're multiplying by 2 each time. So here we're using the iterator for the, I think this is HSB, so we're using it for the brightness. So it's going to get brighter and brighter as it goes through this loop. We're starting with 1 first because 0 times anything is always going to be 0. So 1 is going to be the first value, and then 2, and then 4, etc., etc. So this is going to be brighter, keep getting brighter over time as you loop through it. And we're also using that iterator for the x position as well as the width and height. So it's going to move from left to right, but it's also going to increase the size of this rectangle based off of this iterator. So why don't we go to our P5.js web editor real quick and play around with creating a for loop. Okay, so let's launch the editor. Make sure you're logged in so you can save the sketches that you're creating. You can feel free to change the name as well. So let's do week for loop. All right, and let's go ahead and just delete the draw because we're not going to use that until the second half of the semester. And then in setup, let's create a background. Let's make it white. I'm also going to do a color mode of HSB. Let's do 360, 100, 100, and 100 for the hue, saturation, brightness, and opacity. So the next thing we want to do is play around with a for loop. So why don't we just draw some rectangles? So I'm going to do 4, and then in parentheses. And then we could also add the curly brackets, and then we're going to fill everything in. So inside the parentheses, we're going to create our variable for our iterator. Variable I equals 0. You usually use I. It usually stands for iterator, but that could be any variable name or value. So this could be X or Y or Z or Apple. Doesn't really matter. So you could choose whatever you want, but traditionally I is being used for loops when it can, and it just represents iterator, which is an I believe. So our variable or iterator first, we do a test. Let's just do 5, so I is less than 5. And then we are going to iterate. We're going to add, let's just add 1 to this every single time. So in here, I'm going to add a rectangle. Let's give it an X of, let's just do 0, 0 for the X and Y. And the width and height, let's do 50 by 50. And then I am going to add, let's add a fill inside this for loop. And let's make it red. So again, we're using hue, saturation, and brightness because we are using the color mode up here. Okay, and then above that, I'm going to do no stroke as well, just to make it a little cleaner. Let's hit play. Okay, so we have 1 rectangle. So the reason why we only see 1 is because they're on top of each other. So we're not changing the position when we loop through this. So to change the position, let's do 52. So I'm just doing the width, and then I'm going to multiply that by the iterator. So 52 times I. So the first time it's going to be 0, because we're starting with 0. Traditionally, you always start with 0 when you're programming, when you're working with for loops and like arrays and stuff like that. It's just where we begin. You don't have to necessarily start there. You could start at any value, but it makes sense to start at 0 for most things. So here we're just saying 52 times I. So it's going to be 0 first. So 0 times 52 is 0. And then 1 times 52 is 52. 2 times 52 is 104, etc., etc. So if we play that, then it changes the X value based off of the I value each time. So we're creating a little pattern automatically by just multiplying I times the width of this rectangle. So it's just going to push it over by the width plus like 2 for a little padding in between or margin in between each time. We could also change the fill if we wanted to. So we could say, let's do this by like 10 times I. So this is going to change the hue from red to orange to yellow. We can make this a bigger value. Let's try 30. Hit play. And then it's just a bigger gap in between when it comes to the hue. So another thing that we can do with loops is we can loop through it twice. So we could do a double for loop. So this is great if you're doing a grid of like X and Y objects in a grid formation. So we could loop through the X axis and then loop through the Y axis to create this pattern. You have to use a different variable for the outer loop and the inner loop. So that's why we're using I and J. But it probably makes more sense to use X and Y since we're using the X and Y coordinates essentially for the grid. So we're going to loop through this for the X axis, and then we're going to loop through this for the Y axis. And while we loop through it, we're going to draw a rectangle and change in this case, the brightness of that rectangle. So let's go ahead and do that too in P5. Okay, feel free to save this and duplicate it. I'm just going to replace this. So I'm going to delete this for loop. Let's stop this real quick. So I'm going to delete this first for loop, and let's do a double for loop now. So let's create our outer for loop first. and then our inner for loop. And then we could fill it in. So let's say var x equals 0 for our iterator or variable. And then x is less than, let's say, width divided by 10. We're going to do the entire width of the canvas. And then x plus plus. And then we're going to do the same thing for y. So var y equals 0. Y is less than height divided by 10. Y plus plus. Now in here we can draw our rectangles. And let's just do 10 for now, times x, and 10 times y. And let's make these 9 by 9. Okay, and then let's also add a fill. And let's make it red, 100 for the saturation. And the brightness, let's just make it 100 for now. And then we can maybe play around with that with the iterators too. And then hit play. Cool, so we have a grid of rectangles. So we could also change the brightness. Let's try the brightness by multiplying that by x. So that's gradually getting brighter. Let's try y, see if that makes a difference. So x is going from the left to the right, y is going from the top down. We could also play around with the hue if we wanted to. Let's try 5 times x. So it's a nice gradation, which is kind of cool. So if you want to do gradients, then you could play around with that. And again, if you do times y, it should go from the top down. Yeah, so red all the way down to blue. So we could also play around with, why don't we create a variable at the top for rect size. And let's set that equal to, in this case, let's do 30. And then we can replace 10 over here with rect size. As well as the 9s. So now it's a nice gradient. We can play around with changing that. So if we wanted to make that a little smoother, we can do 5. Or we could do even 1 pixel. And you can play around with that value a little bit more. And then if we wanted to have a little gap, we could say rect size -1 for the width and height. So we can get that gap back. There we go. Cool. So you can play around with the different sizes, the different colors, the different iterator as well. So this also is giving us the full width and height based off of the width and height value of the canvas. We're dividing that by the size of the rectangle. So the rectangles go the full width and height of that canvas. So obviously you could play around with different patterns by just adding more objects in this for loop. So for instance, we have a couple of ellipses here instead of the rectangles. So you can layer on top of each other different objects to create different patterns, different shapes as well. So feel free to try this one on your own as well. Another thing that repetition is great for is creating more complex shape using sine and cosine. So sine and cosine allows us to go around in a circular format and draw points around that circular format, essentially. So if we wanted to draw like a more complex shape, like a pentagon or an octagon, this would be the best way to do that, rather than figuring out point by point where the X and Y position should be for those vertex points. Why don't we play around with that a little bit as well? So we're basically just going to draw this circle and this line and have it go around a circular format. based off of the sine and cosine functions in P5. So let's go ahead and open the P5 web editor and play around with this example as well. So feel free to save this example as well. I am going to stop it and create a new sketch. Okay, so let's go ahead and delete draw. So we're not going to use that. And then at the top, I want to create a variable for our radius. Set that equal to 100. And then a variable for our degree. Set that equal to 90. Then after create canvas, we'll just play around with grayscale right now. So let's do a background color that is like gray. So let's do 220, change it up a little bit. Then let's create a variable for our x value. Set that equal to radius times sine function. And then inside the sine function, we're going to add in our radians and the degree variable. And then for var y, we're going to set that equal to radius times cosine and radians inside, and then degree as well. And then let's create a ellipse. And we're going to pass in that x and y value that we just created the variables for. And let's give it a width and height of 30 is fine. Then we're also going to draw a line from the center point, which is 0, 0, and out to the x and y point. Okay, so let's play that. And so we're starting at the 0, 0 point just because that's a lot easier for us to begin there. But let's translate this down to the center point. So above the var x, var y, let's translate to width divided by 2 and height divided by 2. So which is the center point, the exact center of the canvas. So here we are starting at that center point and we're using sine and cosine, and now we can go around in a circular format by changing the degree here. So this is at 90 degrees. So if we do 0 degrees, it should start there. So it should go from 0 to 360, I think clockwise that way. So if we do 180, it should go point to the top. If we do 220, it should continue that way. So this is a good way to like make a clock or make other shapes as well. So you can play around with that a little bit more to see what values you get when you put in a different degree value. So this is a great option if you needed to loop around a circular format to create some sort of shape. You would want to use sine and cosine to do that. So let's say we wanted to make a octagon or a pentagon. We can use sine and cosine to do that as well as going through a for loop. So putting sine and cosine inside of a for loop, creating vertex points, using end shape, begin shape to draw that shape, we can create a more complex shape. So why don't we play around with that as well? So feel free to save this. I am just going to create a new document. And again, delete draw. And at the top, I'm going to create a variable for the points. So how many points I want to have on the shape. Let's do 6 points. And a variable for, let's just say R for radius. And let's make that 100 points, 100 pixels. Let's do the background as white, 255. And then we basically want to draw a more complex shape using begin shape and end shape. So now when we draw a more complex shape, we use vertex points, but we want to do multiple vertex points using a for loop. So we're going to create a for loop. in between begin shape and shape. And we're going to create a variable I for our iterator, set that equal to 0. And then we're going to set I for the test to be less than the points variable at the top. So right now it's going to be less than 6 points. And then we could say I plus plus to iterate through it. And then in here we could say, okay, var, say just x is fine, equals the radius r times sine, radians, and we're going to use the iterator, so I times, and then 360 divided by points. So we're doing that so we know how many points around this circle format we are going to create the shape. And then var y, we're going to do pretty much the same thing but with cosine. So r times cosine, radians, and I times 360 divided by points. And then we could use those variables in our vertex. Vertex is just going to pass in x and y, these variables that we created. At the top, let's just give it a fill so we can see something. Black. See if that works. Yeah, it works, but it drew at the 0, 0 point, which is great. We always want to draw complex shapes at the 0, 0 point just because it's less complicated to think about. So to move it where we want, then we have to play around with translate. And again, if you're using translate within a lot of other code, you want to use push and pop as well to kind of group all that together so it doesn't affect anything else. So we could just put a translate at the top. Let's put it in the center, width, divide by 2, and height, divide by 2. Try that. Great. So we have a pentagon now, 6-sided shape. So if we wanted to, we could change the points for the variable. So if we wanted to do like 7 sides, we can do that. If we want to do 10 sides, we can do that as well. If we want to do 100 sides, we could do that too. So now it's just more of a circular format. So let's try 3 sides. Got a triangle. It's great. Let's go back to 6. So this is an easy way to make more complex geometric shapes using sine, cosine, and for loops. So next we have decision making. So making decisions is pretty important, especially when it comes to patterns and repetition. Sometimes you want to change one element in that pattern or change a few elements in that pattern based off of some sort of test. So if it's in a certain location, then you want to change it red or replace it with text instead. So this is an example of what we could be doing. This is a poster designed by Paul Rand for Earth Day. So it's a nice pattern. It's focusing on mostly all green hearts except for one area is red, one red heart, and another area is replacing the green heart with text. So when it comes to code, we use something called if statements when it comes to creating decisions in our code, especially in for loops. So an if statement is basically just that. It's asking a question. So if and then a conditional statement is true, then we are going to do something in these brackets. There's also an if else statement. So if something is true, then do this. Else, then do this. So if it's true here, then you want to do this, but if it's false, then you want to do this. And then there's if else statements that can be continued on and on and on and chained. So if you have multiple conditional statements that you want to check for and do something for, then you can do that. So if something, do this. Else if, do something else. Else if, that's blah, 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 blah. And then finally, else. If all of these are false, then this one will run. So you can kind of think of it as like a mind map. So if you go one direction is yes, one direction is no, then you get a different result based off of those tests, based off of that yes or no answer. So when it comes to the syntax, you could say like, if I is greater than 5, then do something. If I is less than 5, do something. If I is greater than or equal to 5, then do something. If I is less than or equal to 5. If I is definitely equal to 5, you use 2 equal signs. If I is not equal to, you can use an exclamation mark and an equal sign. And then there's some more logic. So there's or. So let's say I is greater than 5 or I is less than 10. You can also do and. So if I is greater than 5 and I is less than 10. Or there's also a not logical option as well. I never use this one, to be honest. So here are some examples. Let's just go through these one by one. So if x is equal to 8, then the color is red, else it's black. So if x equals 10, which is not 8, then that's going to be false and it's going to be black. If x equals 8, which is true, then it's going to be red. If x is greater than 3, then red, else black. So if x is, let's say 5, which is greater than 3, then it's going to be red. If x is 0, which is less than 3, then that's false, then it's going to be black. If x equals 3, then it's also false because 3 is not greater than 3. So it's also going to be black. If x is less than or equal to 10, then it's going to be red, else black. So if x equals 10, it's a true statement because x is less than or equal to 10. So that's true, it's going to be red. If x is 3, then it's going to be red as well because 3 is less than 10. If x is 20, it's going to be false because 20 is not less than or equal to 10, and it will be black. So here it gets a little bit more complicated. We have ands. So if x equals 3 and y equals 4, then it'll be red, else black. So if x is 3 and y is 5, then that's false because both aren't correct, so it's going to be black. If x is 3 and y is 4, then it is true, so it's going to be red. So they both have to be correct. They both have to be true when you're using an and. When you see two lines, that means or. So if x equals 10 or y is less than 20, then it's going to be red, else black. So if x is 10 and y is 30, then that's true because it's an or statement. So x does equal 10, but 30 is not less than 20. But it doesn't matter because it just has to be one or the other. And then does not equal, that's what that exclamation mark equal sign, and so both of these have to be true. So x does not equal 3 and y does not equal 1, then it's going to be red, else black. So if x is 3 and y is 2, that is false because x shouldn't equal 3, even though y did equal 2, so it would be black. If x is 10 and y is 20, that is true because x is 10, so it doesn't equal 3, and y is 20 and doesn't equal 1. That's true, so it's red. So there's also shorthand when it comes to if statements. You don't necessarily need those curly brackets every single time. You can just put it on 2 lines like this. So if x equals 8, then the color is red, else color is black, etc., etc. So that's just another option if you wanted to try it with shorthand. So here's a simple example where we're looking at a grid of circles and basically saying if x equals 1, it's going to be red, else it's going to be white. So this is what you would see as you're looping through this for loop. When x equals 1 for this iterator, then it's going to be red, else it's going to be black. So you can count from 0, 1, 2, 3, 4 for the x-axis. So 0, 1, x equals 1. So this entire column is going to be red. here you can say if x equals 3 and y equals 2, then it'll be red, else it'll be white ellipse. So again, we can count over from the x, so 0, 1, 2, 3. And then from the y, it's 2, so 0, 1, 2. So it's just going to be one value that has a x value of 3 and a y value of 2. So here we switched it up a little bit. So if x equals 3 and y is greater or equal to 2, then it's going to be red, else it's going to be white. So again, let's count over. 0, 1, 2, 3. That's right. So we're in this column. And then y should be greater than or equal to 2. So it should be 2 and above. So this is 0, 1, 2. That's red. And then everything above 2, so 3, would also be red. So here is an or statement. So if x equals 3 or y equals 2, then make the ellipses red. Otherwise, it'll be white. So let's look at the x-axis first. So if it's 3, 0, 1, 2, 3. So this entire column should be red. Then for y, if it's 2, 0, 1, 2, this entire row should be red. So let's try and play around with that in code as well. Okay, again, feel free to save this if you want to keep it. I'm going to create a new document and delete the draw function like usual. So let's create a couple of variables at the top and set this up. So I'm going to create a variable for our max column, set that equal to 5. Create a variable for max row, set that equal to 4. Create a variable for circle r for radius, set that equal to 60. And then let's also create some variables for spacing. So I'm going to do that inside of setup because I'm going to use the width and height variables. So var x space equals width divided by max column, and var y space equals height divided by max row. Let's create a background color. Let's do black. And let's create our for loops. We're going to do double for loop. And the outer for loop, let's do var x equals 0. X is less than max call, and x plus plus. We're going to do something similar for the inner for loop for y. So var y equals 0. Y is less than max row. Y plus plus. Inside here, let's create our ellipses. And do x times x space, y times y space, and circle r, circle r. Okay. Oops, looks like I misspelled space for y space. So let's go back up there and fix that. There we go. All right, so we could also, let's translate it down a little bit and over so it looks a little better. And let's translate it by circle R and circle R. A little bit too much. Circle R divided by 2. Let's try that. That's fine. So you can play around with the translation a little bit more if you want it to be a little more perfect. So let's also create some if statements. So in our double for loop, we're going to add some conditional statements. And let's change the color. Let's just do the last one. If x equals 3 or y equals 2, then let's make it red. So we're using RGB. Let's change the color mode just to be consistent. Let's do color mode HSB 360, 100, 100, 100. Okay, so let's do fill red, full saturation, full brightness. And for the else, let's do white. So that's just saturation is all the way down and brightness is all the way up. Let's try that. Cool. So we could also play around with this. So let's try just 3. All right. Let's try greater than or equal to 3. Cool. So you can play around with different iterations of that. You can do and as well. Let's do y equals, let's do 3. So y equals 3, 0, 1, 2, 3, and x is greater than or equal to 3. So 0, 1, 2, 3, and then anything above 3. So feel free to play around with different if statements and conditional statements here to see what you would get. Just remember that it has to be, x has to be less than this value, and y has to be less than this value. But you can also play around with that too. Let's see if we make that more. And we got more. Let's go back to, let's try 6. Cool. So I actually made an example of this Paul Rand poster in using code, using P5. So I'll share with you that example in the description as well as on the class website. So feel free to check out that and look at the code and see how I created the heart shape, but also used conditional statements and for loops to create this design. So the next and last thing that I want to talk about is randomization. So I think this is one of the more interesting and fun aspects when it comes to playing around with the code, especially for design, is to apply random values to different design elements like position, rotation, color, dimensions, opacity, etc. So you can use random values to design some sort of design system, but add some randomness to it to have it change every single time it loads. So it's going to be slightly different every single time. So here are 2 posters that are not designed with code, but have a feeling of randomness when it comes to the design. I believe both of these are by Paul Rand. And it's just like the position and the colors of these dots and rectangles in these designs give it a kind of random feeling to it. So random values have also been used in like branding. For example, the MIT Media Lab logo used random values with a design system with code to generate a completely unique logo every single time it ran this code. So it's all going to live within the same design system. So everything it generates is going to look similar and look like it's part of the family. But the position of these rectangles are going to be changing constantly. The location of where this kind of light graphic is going to be changing as well. The colors are going to slightly change as well. So everything looks like it belongs together, but it's going to be slightly different every single time you run this code. So here are a few more iterations of the MIT Media Lab logo. I think they use different colors for different departments, but the positioning of all the elements is all randomized every single time you run the code. The city of Melbourne actually created a generative logo as well using random values. But again, everything is based off of this M shape. So all of the randomness that goes on is inside of the M shape. So it still has a cohesive brand that kind of works regardless of what the pattern is inside of it. And that pattern inside, that design inside, is randomly generated each time. And this is the project that I showed you by Rune Madsen. It's called Tiny Artists. And again, it's the same idea, it has a design system associated to it, but every time you execute the code, it's going to be adding some randomness to it, whether that's the size of the shape that's making up the overall shape, the color system, the color scheme that is being used to create this design. There's a collaboration when it comes to the designer and the machine, your computer. When it comes to randomization, you're kind of co-designing the piece with the computer. So when it comes to random values in P5, it's very easy to create random values. So there's a function called random. And then if you pass one value into it, that's going to give you a random value between 0 and 100. And that's going to give you a decimal point, a float. If you wanted to kind of optimize that a little bit so it's not starting at 0, you can do that too by adding two values in there. So if we say 50 and 100, then it's going to give us a random decimal point value between 50 and 100. If you didn't want to use a decimal value, if you wanted to use a whole number, you can use the round function to wrap around the random function, and that'll just round the value to the nearest whole number. You could also use, instead of round, if you wanted to use ceil, it'll round all the way up, regardless of where the decimal point lands, to the highest whole number. Floor goes to the lowest whole number. Round goes to the closest full number. And then min and max are functions that find the minimum value in a series or the maximum value in a series. So here's an example of playing around with randomness and the position of a rectangle on the screen, the background color, the rectangle's color. So this is a really good example to start with. And this is just using a random value between 0 and 100, but we can optimize that if we want to as well. So let's play around with this one first. So again, feel free to save the sketch. I'm just gonna stop it and create a new one. And delete draw. So in setup, let's do a color mode, HSB. Again, 360 for the hue, 100 for the saturation, 100 for the brightness, and 100 for the opacity. And then I'm going to create a variable for a rect size. Set that equal to a random value between 0 and 100. Let's create a variable for x and add a random value for the x location of this rectangle. Let's do it be a random value between width and minus rect size. So this will just mean that it's going to be anywhere on the screen, but it's going to stay on the screen based off of this rect size. We're subtracting that, so it won't be off the screen at all. Let's do the same thing for y. Random height minus rect size. And let's add a background color that is also random. Let's do a random value for the hue. Then let's do no stroke for the rectangle. And let's draw the rectangle first, based off of the x and y variables we created and the rect size variable. And let's also give it a fill. And let's do a random value of 360. And 100, 100. Okay, let's try that. Cool. So if you keep on hitting play, then you're gonna get a random rectangle with a random color and a random background color. So sometimes it's completely random when it comes to the color, so it's any possible color. And it's any possible size between 0 and 100. So it could be like microscopic, like less than a pixel if we get a random value that is less than 1 pixel. Let's make this a little less random, so it's not completely random. So let's do a range for the size, so it's not microscopic. So let's do between 20 and 100. So now it won't get less than 20. And for the color for the background, let's do a range between like 270 and 360. So it's always going to be in that higher hue value for the background. And then let's do the fill color to be kind of more contrasting. So let's do 90 and 180. So now the color for the rectangle is going to be more contrasting in color when it comes to compared to the color of the background. So we won't get the same color or similar colors, so the rectangle will stand out more on the background color. So this is using the min and max value for the random function. So if you have one value, again, it's just going to be between 0 and that value. If you have two values, then the first value is the minimum value and the second value is the maximum value. And then it gives you a random value in between those two. So you can imagine how you could do this with color theory and color schemes. So you could create a color scheme and have a random value for the original color, for example. So if we wanted to have like a analogous color scheme, but have a random start color every single time we run the code, we could do that. So every time it runs, it's always going to be an analogous color scheme, but it's always going to start with a random color. So it could start with reds, it could start with blues, it could start with greens, etc. So you could play around with randomization and color schemes as well. So feel free to do this one on your own. You can also play around with random values when it comes to sine and cosine to make more organic looking spiky shapes rather than like an octagon or a pentagon. You can have random values that make those points go in and out and make like a little spiky ball. So this is another example of what you can create. So feel free to do this one on your own as well. And I will have examples for these in the description below on the YouTube channel as well as on the class website. So you just click and play around with the code as well. So an alternative to the random function is the noise function. And that creates it's called Perlin noise. So Perlin noise is a random sequence generator producing a more natural or harmonic set of numbers than the standard random function. It was invented by Ken Perlin in the 1980s, and it is used to produce much more natural patterns and environments. Like on the left here, it produces more like a vein-like system. But on the right, you could also create something that's more like fabric-like or smoke-like. You can create some really interesting natural-looking environments and effects using noise. So Perlin noise is actually used in like the film industry and the gaming industry to create like really realistic, randomly generated environments. So you can do stuff with 3D elements to produce these randomly generated environments in 3D. And it's great to produce textures and patterns using random values too with Perlin noise. So you can recreate like fire and smoke and clouds and water, wood grain, fabric, playing around with Perlin noise. So here's an example that compares the random function with the noise function. So random is very much random, so it's going to be much more spiky. Noise is kind of learning from the previous points and the previous value. So it's not going to be as spiky. It's going to be more of like a nice natural progression from one point to the next. So we can play around with noise a little bit in P5. So we're going to be using the noise function, and it's going to be passing in a noise count inside of that function. And that count has to be updated every single time you loop through it. Otherwise, it's just going to give you the same value. So that's why we're doing a noise count plus equals 0.02. We're updating that noise count value every single time we loop through this to slightly change it a little bit here and there. So why don't we play around with this in P5 just to see what we can get when we change the different values for that noise count. So again, feel free to save this if you want. I'm just going to stop it and create a new document. And let's go ahead and delete the draw function again. So let's just create a background color. I'm just going to keep it with RGB for now. It's fine. We're not going to do anything with color. Let's do it white. We are just going to be playing around with a line using the vertex points. So let's just create a stroke color of black and a no fill. We don't want to have a fill. And then let's do a stroke weight of 3 pixels. All right, so let's do begin shape and end shape. And we are going to loop through this to create our line that is going to have some like mountain-like formations. So let's create a variable I equals 0 and I is less than width. So we're going to go the full width of the canvas, and let's do plus plus. So above the for loop, we're going to create a variable for our noise count, set that equal to 0. So we're going to initialize it, but we're going to update it each time we loop through this for loop. So let's create a variable for y and set that equal to the noise function. And we're going to pass in the noise count variable we just created. And let's create a vertex. We're going to pass in for the x, just the I value for the iterator. And for the y, let's pass in the y value. And let's just do y for now and see what happens. And let's create a noise count to increase this by a little bit each time we loop through this. Let's do 0.02. Okay, let's run that and see what we get. Okay, so we got a line at the top. Let's bring that down. So let's do a translate. So x should be 0. We're not going to translate at the 0. We're not going to translate on the x-axis, but we are going to translate on the y-axis to the center point. Okay, so we have a little line here. It doesn't look like it's moving a lot, but it is moving a little bit. So one thing you can do, you can play around with the noise count. Let's just try that first. So it's getting a little bit more jaggedy, but it's still a really small value. So let's go back to 0.02. And so actually this is a good example of when we want to use print. You can print y to the console. So this is going to show us what value we're getting when we're using y. So everything is below 1 point. So that means the noise value that we're getting is a really low value. So we got to increase that value to really see something when it comes to the y value for the vertex points. So let's also multiply this by, let's just do 10. Let's do a smaller value first and see what happens. Okay, so it's getting a little squiggly, which is nice. So it kind of looks like it's someone drawing a line by hand. We can increase this a little bit more. Let's try 50. Okay, there we go. So now it's starting to look more like a mountain range a little bit. So now that we have something that we could see a little better, we could play around with the noise count too. So let's try 0.2 and see what happens. Okay, so the higher you get with this value, the more kind of completely random it gets. So let's try 0.005. So the lower you play around with this number, then the smoother it gets too. So that's something to consider when you're designing something. So do you want it to be more spiky or more smooth? So here we're just using the noise function for one value. So we're just using for the x. We could also pass in a y value and also a z value. So if you're playing around with 3D, then you can also play around with the z value for that. But we're just doing it one-dimensional, basically, just playing around with the x value right now to keep it simple. So feel free to play around with this value to see what you get. You could also play around with this 50 value to see what it looks like too. So explore different numbers there to see what you get. So obviously you could play around with noise in many different ways. So here's another example that uses it to, rather than doing completely random spikes, it's kind of a more smooth transition from spike to spike when it's creating this shape using sine and cosine. So that's another example you could play around with. Again, I'll add a link to that example in the description as well as on the class website. And then here's another example that uses noise but on the x and y axis, so it's getting a little bit more dynamic. And this actually creates a really nice pattern when it comes to kind of generating like a smoke effect or clouds going through the sky. So this is actually looping through every single pixel on the canvas. So it might take a little time to process and to run this. But again, I'll add a link to this code in the description on YouTube as well as on the class website, so you can take this code and kind of play around with it a little bit more and explore different things like changing different values to see what comes out. So as a little class assignment, I want you guys to play around with loops and if statements and maybe randomization by being inspired by this Soluit piece. So this is an actual piece by Soluit that was actually created. So the piece is just 6 white geometric figures, outlines, superimposed on a black wall. So I always like to give this to my students and see how they interpret it and what they design based off of those instructions. So I think this is a good way to kind of explore and play with loops and if statements and randomization. So have fun with this project. So that's all I have for today. So that was talking about randomization, if statements, and for loops. So if you have any questions, like always, feel free to email me or shoot me a message on Slack, and I'm happy to answer them. Make sure you check out the class website for the homework assignment for this week. And again, just let me know if you have any questions. All right, thanks, and I'll talk to you guys next time.